you that still can't get in, like I said, just send me an email. I will call Pearson this afternoon and say these two students cannot, they signed in class, but the course is not popping up in their account.
If
So
it's
put
still
them
not
in.
working by tomorrow, do we just need to reset the whole thing?
Can you get in D2L?
No, I can't get in anywhere.
Can't get in anywhere, okay. Did you signed up for mine though, right?
Yes.
Okay, I will text you as soon as I know that I've gotten you in,
Okay.
okay? Okay, let's talk about chapter 1 and finish it up, or try to finish it up. Are you being hateful? Maybe it's on the D2L page. And I believe we left off I think we left off here, is that right? Linear cost functions. Okay, a linear cost function. Now this, again, there are cost functions that are not linear, but because this is strictly about linear equations in Chapter 1, we're going to talk about linear cost functions. And actually, a lot of cost functions are linear. They don't have really but two kinds of cost, marginal cost and fixed cost. The fixed cost is going to be represented by the B part of the equation, because that's where if you didn't make anything, it cost you that much just to have your business open. So that's for things like rent or mortgage on the building, utilities, things like that, that they're going to cost the same no matter how many things you make or don't make. The marginal cost is going to be the slope. It's going to be the cost per item. That's the M. So X is the number of items you make, and the cost of making X items is going to depend on two things. Your fixed cost that you're going to have with you no matter whether you make any or not, and then the cost per item that it costs to make whatever it is that you make or produce. So, as an example, the marginal cost to make X batches of prescription medication is $15 a batch. So the actual materials to make the drug are only $15. But the cost to produce 80 batches is $1,930. And they want us to find the cost function given that we know that it's linear. Well, we've got two pieces of information here. We've already got the slope. That's 15, because it's 15 per batch. And then we have a point that 80 for X produces a cost, C of X, or C of 80, of 1930. So we use that information with our linear cost function, C of X equals MX plus B, and plug in that the cost of 1930 comes from making 80 batches, and then the marginal cost is $15 per batch. What we don't know is we don't know the fixed cost. But when you solve that equation for B, then that gives us that B is $730. So your cost function then is C of X equals 15X plus $730 for producing X batches of the medication. Does anybody have any questions? Did I give you all the notes handouts for this? Or have you printed out? Okay, let me show you where you can actually get the notes. If you're in D2L, on the content page, go to chapter 1. Oh, the only thing that's there is the PowerPoint notes. Let me fix this. Go to my other file because I've got class notes in it, and apparently I didn't copy them over. I'll go copy them for you, so you won't have to print them. Okay. Another example of a cost function, and this is about widgets. A lot of times they just use a generic term like widgets. I don't know what they're making here or what a widget is, but it's an abstract unit of production. The total cost to produce 100 widgets is $7,965, and the company has fixed costs of $7,145. So they want us to find the cost function. Now this time what we've got is we've got a point, 100, 7965, and then we know what B is, but we don't know what the slope is. We know B because it says the fixed cost is 71.25. So what we have to do first here is find the slope. So in order to find the slope, you're going to plug in the information you do have into the function and then solve for M rather than solving for B. You can't use the slope formula because you don't have 2 points. You've only got, well, you do have 2 points. You could use 0 and the fixed cost for the other point. But it's easier and faster probably just to do it this way. So what you're going to do is you're going to solve the equation where 7965 was the total cost for making 100 widgets, with 7145 being the fixed cost. We're going to find the slope. And so what we come up with is 820 is equal to 100 times M, and then we'll divide both sides by M and determine from there that 8.2 is equal to M, so that's the slope. And the marginal cost when it's 8.2 is $8.20. So you want to say that the function is that the cost function for these widgets is $8.20 times every one that you make, plus a fixed cost of $71.45. The last topic in this chapter is break-even analysis. And break-even analysis takes place when the price, when your revenue function is equal to your cost function. You're making a profit when your revenue function produces more than your cost function does. And you have a loss when your cost function exceeds your revenue function. So the thing that you need to remember is that revenue is the price per unit that you sell. So you multiply the price per unit times the number of units, but your cost function is going to be a y equals mx plus b kind of function where you have marginal and fixed costs. And if you want to find your profit function, you'd simply take your revenue function and subtract your cost function from it. And the break-even quantity can be found either by setting revenue equal to cost or by setting your profit function equal to 0. And remember that the break-even point is always 2 numbers. It's going to be an ordered pair. So in a place that's making some kind of animal food, the units of feed is on the x-axis and the cost of producing and the revenue from producing and selling X units is on the y-axis. And your break-even point is when they sell 25 units and they make 600, whatever units the dollars is. It might be $600, it might be $600,000. Once they pass the break-even point, they're making a profit. That's where the company wants to be. They want to find out what their break-even point is, because they're operating at a loss prior to reaching that level. So that is it for that section. Questions? Okay. The last section may be something that's a little bit unfamiliar to most of you. How many folks had problem stats? I know several of you did. Okay, those of you that just raised your hands, this is going to be very familiar to you, and it makes it a lot easier for you. Those of you that have not had it, this is not a hard thing to do, because we are not going to do the big ugly formulas that are in the book. We're going to use the calculator to do all of this work. So we're going to talk about something called the least squares line. And we've actually already done one example at the end of the first section. We actually had a set of data and we fit a line to it. We're going to talk a little bit more about that now. So this table lists the number of accidental deaths per 100,000 people in the United States through the past century, and the source is the National Center for Health Statistics. Somebody that might be interested in this data would be an actuary. Actuaries make a lot of money for figuring out things like this. They set insurance rates. So those of you, since all of y'all are in business careers, you might want to look up actuary and see if that might be something you would want to do. So we want to calculate the least squares line for this set of data. Now I'm going to take a slightly different approach from what the book does, because the book, and it confused me when I looked at it, because the book set the graph up with the labels going from 1920 to 2010, but then it started referring to X as being 120. And then other numbers, that they align the data. We're not going to do that for the linear functions. We're just going to use this data as it is without worrying about doing anything called aligning it. Later on, when we get to other models, we will align the data so that if we have a base year like 1920, that'll be year 0. But this one, we're just going to use the years as the input. So this is how we're going to do the problem. I gave you lots of screenshots here. You're going to go to your y equals, and you're going to make sure that first screen looks exactly like that. So your y equals menu, all you do is just get your calculator. Let me pull mine up. Turn it on. I'm going to clear it. Go to y equals. Now see, mine's got a bunch of junk in it. Before you ever start a regression line or least squares line problem, what you want to do first is you want to go to your y equals and you want to clear out everything that's there. And if you have a black box on any of your plots, you want to put your cursor on the one that has a black box over it and press enter. So you want to make that screen look just like that first screenshot there. You don't want any plots turned on. You don't want any equations on the y equals menu. You probably even want to scroll down and make sure there aren't any equations at the bottom of the screen. Because if you don't do this first and there's stuff in there, you're likely to get an error message. So this just keeps you from being frustrated. Then from there, the first thing that we're going to do is we're going to go stat and enter, because we want to put some data in here. So we're going to start out with the years, and I'm going to go back to the data screen. And we're going to do 1920, 1930, 1940, 1950, 1960, 1970, 1980, 1990, 2000, 2010, and since there's still some numbers in mine, I'm going to delete until the rest of them have gone away. Now I'm going to go over to list 2, 71.2, 80.5, 73.4, 60.3, 52.1, 56.2, 46.5, 36.9, 34, and 39.1. So now we've got the data that's on the calculator. Next thing we do is we press the second and the y equals, and we go into plot 1, and we make that screen look just like this one. And since I know we've done this before last class period, I'm not going to go as slow as I normally would. So once this matches, then we're going to hit the zoom key, and we're going to go to zoom stat, which is the number 9 function. And obviously I made some kind of mistake because those data values were not that far out of line. So what I need to do is go back and see what my mistake was. Let me go back and look at edit again. 20, 30, 40, 50, 60, 70, 80, 90, 2,000, not 200. Okay. So then I'm going to go back and I'm going to do zoom 9 all over again. Okay, and there's our data. Now that data isn't nearly as linear looking as the data we looked at the end of section 1.1. It's not as tight a correlation. But it does, you can see where if you drew a couple parallel lines on either side of that band of dots, that, they're pretty much within a fairly close together set of parallel lines. So it might be linear. Now I will give you, it might also not be linear. It might have been that this was a cubic function, but we can't say for sure. So we're going to fit the simplest function to it that we can. And the simplest function would be the linear function. So then we're going to press stat and go over to calc. And then we're going to go down to number 4, which is linear regression. And then we're going to tell it that the x's are in list 1, so that's second and 1, comma. And that the y's are in list 2, so that's second and 2, comma. And because we don't want to have to write down the information and go manually enter into Y1, we're going to press the vars key and go over to Y bars and hit enter, which takes us to this last screen, and hit enter to copy that onto the home screen. So we're going to store this equation in Y1. And this is what I see. Now you may not see anything but that, and that's okay.
What did you do? How do you save it under the Y again?
And we'll go back through that part. On the calculator I will. Go stat, calc, down to number 4. Second 1 for list 1, second 2 for list 2, comma, and it's the vars key. It's right next to your clear key. Okay? And then when you get there, you want to go to the Y variables, or the Y bars. And we're using function mode throughout this, so you'll always just do vars, Y bars, and then enter to choose the function. And then enter again, because we're always going to use Y1. And it gives us this. Now, if you don't get R squared and R, that's okay. I'm going to walk you through how to get that in just a minute. Now, if we look at the graph, we can see that, like I said, that problem in 1.1 was a really good fit. This is not quite as good, but it still, the line does fit fairly well. So what that tells us is, first of all, the death rate from accidental deaths is decreasing. And it tells us how much it's decreasing. It's decreasing by about 0.506 per X is the year, so whatever year that is. And it also tells us that evidently, initially, when they first started collecting the data, that there were 1,048, let's call it 1,049 accidental deaths per year in whatever year zero was. So the death rate is negative 0.5056 times the year plus 1048.4764. And it's okay to round these. When you're doing my my math lab, when you do my math lab, be sure and read the rounding directions. Because you may put in a perfectly right answer and yet not round it the way that it told you to, and it's going to count it wrong. If it does that, you don't have to go back and redo the problem. But you do need to let me know that you did that, and then I'll go in and adjust your grade. I'm not going to make you have a problem wrong just because you didn't round exactly the way that it said to. But it'll just save you some frustration. Now, example 2 is related to example 1. It says, can you use that equation to predict what the death rate would be in 2020? Well, yeah, you could. You could either plug in, and this is where they got me off guard, because they're counting time from 1900, so it's been 120 years. But we didn't put our data in that way. So what we're going to do is, first of all, I'm going to go look at the window and notice that I can't go to 2020 because my calculator isn't going as far as 2020. It's only going up to 2019. Now I'm going to show you what would happen if I tried to do the rest of this without adjusting that. So I can go second trace and tell it that I want to put in a value, and I want to put in the year 2020. And it's going to say I can't. And the reason that it can't is because it can't see 2020. It can only see up through 2019. So what I do to keep that from being a problem is I just go over here and I increase 2019 to 2029, which is what I'm showing you on that first window. And I actually scaled my graph to 100 so that I could actually see the tick marks. So this is the end of the century right there. And 2020 is now on this screen, so I can go second, trace, choose value, and tell it, okay, I want to see where it's 2020. It says, okay, in 2020, the death rate would be 27.2 times, remember these are in 100,000s per year. So the accidental death rate 2020 is 27.2 per $100,000, or 100 people, 100,000 people in the population. And then they made the note, and this is very true, we observed that the accidental death rate began to go up after 2000 and was 39.1 per 100,000 in 2010. So probably this extrapolation, it may not be accurate, because we notice that it does, it's declining, but then it appears to be going back up. So maybe the linear model isn't the best model. We'll probably come back to this same problem when we get to chapter 10 and talk about fitting a different model of this. The next question is, what year is the death rate predicted to drop below 26 per 100,000? Well, in this case, we're actually looking for when is our equation set equal to 26, so we can find out when it drops below that. And in order to do that, without having to do a lot of arithmetic, although the arithmetic's relatively easy, what I did was I went back to my window, and since I really want to see what happened at the beginning, I'm going to change my y-min to 0. And then I'm going to go into my y equals, and I'm going to put in another line. And I'm going to put in the line so that Y2 is equal to 26. I want to know, when did it get less than 26? Within what year did it drop below 26? And then I'm going to calculate where these two lines intersect. So I'm going to hit graph. And there comes the value of 26. So I know that it went below 26 right there. Now I need to know what that point is. So I'm going to go second, calc, down to number 5 for intersection. And press enter 3 times. And find the intersection is at 2022.39. So sometime during the year 2022, the model predicts the death rate will go down below 26. So this is their graph, and you see why I said it was kind of weird that they used 120 when then they labeled the graph with 1920. But what you notice here is that the line sometimes, at this point, it is over-predicting. The next point, it's under-predicting. Then it's under-predicting again. And then it's pretty close in the 4th year. It's pretty close in the 5th year, but it's under-predicting by a little bit in the 6th decade. And this in the 70s, it's pretty close. The 80s and the 90s, it's pretty close. But by the time you get to 2010, it's under-predicting by quite a bit. So this is something that I'll give you the word for it. Those little lines that I've got in here, those are called the residuals. And what the least squares line does is it makes the sum of the residuals, the sum of the error, as small as possible. So it's better than us trying to fit a model of the data if we let the calculator do it and do it with the formula. And even though we did it with the calculator, this next slide points out that you can, if you're making a report that you need to present to somebody, you can use Excel to create the graph. And then you can make it pretty with all kinds of graphics and stuff like that. So if we have time, I may even show you in the later chapters how we can use Excel so you can print the graphs out. This correlation coefficient that we're going to talk about here, how many people did not get R or R squared on their calculator? Anybody? Okay, those of you that did not get it, those of you that did don't have to worry about this, but those of you that didn't get that, press second and mode to go to your calculation screen, your home screen. And then press second 0 to get to the catalog screen. You'll only have to do this once. You'll never need to do it again. And then scroll down. And you want to see the word diagnostic on. Put the little triangle in front of diagnostic on and hit enter twice. And it says it's done and you didn't see it do anything, but if you go back and redo your linear regression, and I'm just hitting second enter to make it repeat my last commands, you should, when you do that, now see the R and the R squared. Now for the problem that we just did, the R value is very close to -1. It's -9.4 or 0.94. You don't need to worry about what the R squared means. That's the statistics concept. But as long as R is close to 1 or -1, you have a fairly strong relationship. If it's close to 0, then there is a weak linear relationship. Both of these show that R is close to 0. That's only because you can't fit a line to it. You can see a pattern here. Obviously, there is a relationship between those two, the X and Y variables in that graph, but it isn't a linear relationship. And here, it's just a circular relationship. Okay, and that's not even a function. So, as I said, our R value was -0.94, so that's fairly close to -1. Example 5 talks about the expenditure per pupil, and I just put the data in there. And what happens here is that if I were to try to fit a regression line to that set of data, number one, it would be a very strong correlation anyway, because even though the data are clumped up, they don't look very linear. So I can't discern a clear linear pattern. But if I did fit a line to it, the line is probably going to miss most of that data and try to come down here and pick up that one point, and that happens to be the District of Columbia. So before I would even try to fit a model of that, what I would want you to do is I would want you to take out the District of Columbia data value there, and then try to fit a model to it, okay? So we have finished our coverage of Chapter 3, and you can go take a much-deserved vacation for a little while. Enjoy your Labor Day holiday. Have some fun, and I will see you next Tuesday.
I sent you a message about line not working, just to remind you.
Okay, yeah, that's fine.
I'm glad I'm not the only person.
I have to submit what I just, no, I
Which part?
That's why I wanted y'all to email me, because I was gonna take it back to the road and my math class. That was the other one.
I think that may be mine. Yeah, I don't know, I'm printing stuff, so I don't.
Yeah. Wait, I'll have to check this out.
Yeah, I'll check it before I can see it.
This is yours.
Did you get me counted here this morning? I came in late.
Did you sign up in my math lab?
Yeah.
Okay, as long as you sign up in my math lab, I'm gonna know you were here.
Alright. Are we gonna have to, pay for that one?
No,
Alright.
no, just don't opt out.
Alright.
Stay opted in, and it'll charge you the $99.95, because even if you buy it straight from Pearson, it's gonna cost you $5.
Is it already charges for that? Or
It actually will, they'll charge you Tuesday, I think is what they said.
Alright. I was looking a little bit about it last night. I wasn't sure about it.
Okay. Yeah, it's showing me what you did, and I can see that you didn't finish. Do you still need to be able to get in?
Yeah, it won't come up on mine. So I'm gonna try to go back, and we were not doing it today.
One of those, I'll take the due dates, let me go back. That's what I was thinking. No, it's the second. So you still should be able to see it, because it's just the first. Well, you got 90% on it, though. Was there a reason you were trying to redo it?
No, I didn't finish it. There was 26 questions, and I only got through like 6. Because this is what it is. Chapter 1 is only got
Oh, I see, okay.
got through a little bit of it.
Because I was looking at your skills check, I'm
Yeah.
sorry.
I was gonna go back and try to bring those up, just get it when I can, but they wouldn't let me go back and finish it. You think it was where it was a test and I just submitted it?
It might have been. Let me go look at the settings. Let me go back and look at the settings.
I think it did say submit instead of save.
Yeah, you can't save in the middle of the test. You
Yeah,
have
if
to
it's a
finish.
quiz, you can't save, you have to finish.
Okay. Is there any way I can go into my math lab on, that we just signed into and do it again?
Yeah, you can surely do it in there. The settings I have. Well, and one thing too, that's not even assigned to you. I didn't assign the review quizzes, at least not that one.
Because I was just doing the homework that said the 2nd through the 5th. I was trying to get it back. And that's what it was anyway, so.
I wonder why. Because it's not even assigned.
There's 2 of them that's due on the 2nd, and then there's what, 3 for the 5th?
Yeah, what's due on the 2nd is the Chapter 1 Skills Check quiz, and if you did the homework, it's due on the 2nd also, because that's, the only reason it's there is to help you with the quiz. And then I'm gonna omit that grade. And then on the 5th, you have section 1.1, 1.2, and 1.3 are done. And the Chapter 1 review's got a date on it, but it doesn't, I mean, it's not assigned.
Because I done the homework and then I went to do the quiz and then I guess I just submitted it thinking it would save and then it wouldn't let me back in.
Okay, well, now, actually, it should have been assigned, and that may be another reason it won't let you back in. So I'm not going to adjust it here. I will adjust it over in the other one.
Okay,
and
I'll
you'll
just
be able to
finish
do it
what I
there.
have on DTL
Yeah.
and then go over there and do that.
Yeah, and I'll send everybody a text message when I get the due date set up to where you can get in and do it.
Okay, thank you.
Alright, so, I don't know if you ever read this whole thing, so we, with Alcus and stuff, but like, I work on the road.
Okay.
And I got like, my employer called me and was wanting to know if I could go on the job. Not next week, the week after. And I think there's one here, it says there's something like on the 12th and the 16th, I believe. Is that right? Yeah, the 12th and 16th. Is there any way, like, I could catch all this up before I left? And
Yeah.
come back?
Yeah, because it's all open to you.
Okay, I just wanted to, like, let you know,
Okay.
see if that was okay, like.
Yeah, that's fine.
Because they probably do just, because the job starts on the 12th and I'll be back on the 16th.
Okay. Yeah, you can go ahead and work ahead on your homework and then just send me an email and remind me that, don't forget I told you I was going to be absent for work on.
Okay.
And then if there's anything that I can tell you to do to make up for it.
Yeah, I mean, I want to get myself ahead,
Yeah.
so I don't want to have to come back and I'm behind. I want to be
Yeah.
ahead when I leave.
It would be better to be ahead, so yes,
Yeah.
that'd be fine.
And if it's not possible, I mean, I can always call me.
And your first test is going to be on the 13th.
13. That's a Tuesday. Would I be able to take that test before I left?
Yeah,
Okay.
I can work that out for you.
If I could take it before I left, that'd be perfect, because that would be the week I'd be gone.
Right.
Yeah, I wanted to check with all my teachers first. So far, everything seems
Yeah,
good.
for me, that'll be fine.
Okay.
Okay?
That's what I'm gonna try to do. Maybe try to catch up, and maybe try to take that test, so that Tuesday, maybe like that Thursday or something. That will be
Yeah, you can take it on the 8th.
something like that would be fine.
Okay.
Try to find out.
All right.
Yep, thank you.
You're welcome.
Have a good
You
break, good weekend.
Yeah, it'll be nice not to have to worry about trying to make all of this work for a couple of days.
It's been a hassle. This ain't the only class, it's like that.
Oh, I know, it's been all of them, and it's been very frustrating for everybody.
It really has been. But, yeah, well, I'll see you next week.
Okay, thank you.
Thank you.